when my 2-year-old runs a fever and I have to stay home, and it happens to be on a lesson like this, I can just tell my kids, watch the videos. Right? You get what I'm saying? You get it, right? Because we've discussed this too, right? Why do I have to stay home? We talked about floor seats, right? Bulls floor seats. Bears 50-yard line, right? The house in New Orleans. All of these things are important. Right? All right. Let's talk about solving trig equations. Now this just says solve. Very straightforward. We're going to keep that. We have to keep what we do in this solving process to fit that, right? Very ambiguous, very open-ended. Just solve this. So we'll touch on that again when we're done. But the method for solving trig equations is just like solving for a variable, only we have to consider this our variable. We have to isolate that trig term if we can, right? If we can get those together on one side, that's the idea. So if we had an equation that said 5x plus 1 equals 3x, and I said solve, you would want to get your x terms together, get your constants together, and then get the variable by itself, right? This is kind of touches on that idea of substitution that we talked about the other day, which is you can do this. You can go off to the side and say, you know what, I'm uncomfortable solving for sine theta, so I'm going to call sine theta x. And anywhere I see a sine theta, I'm going to put an x. Now here, you all should be able to solve for x here. Subtract 5x from both sides. Divide both sides by -2. We get x equals -1/2. But remember that from the beginning, x is sine theta. So we have to make that final substitution where we have, okay, it's really sine theta equals -1/2. And then to get theta, which is what we're solving for, x was not our variable, theta is our variable, right? This angle that's inside here, I want to know what angles have a sine value of -1/2. We have to undo the sine. We have to do the inverse operation of sine, and the inverse operation of sine is sine inverse, right? Only we write it like this, arc sine, that's an R, arc sine on that side, and then we take the arc sine of -1/2. Arc sine and sine are inverse operations, so they will undo each other. And then here, we're looking for a pi value, an arc value on the unit circle, or a pi value with a y coordinate because it's sine, so a pi value with a y value of -1/2. And because the directions just say solve, this is where things, we got to figure out how we're going to interpret this. Because the directions say solve, they're not limiting me when we solve like this to that range of values that we discussed with inverse trig. All right? So we can list any angle that has a y value of -1/2. And those values are in the fourth and third quadrants because our y values are negative down here. So that would be 7 pi over 6 and 11 pi over 6. Or you could call this negative pi over 6 if you wanted. Okay? But it's not just those, right? So if you will, here's pi over 6, right? Here's the positive x-axis. Imagine my shoulder is the origin, okay? Pi over 6, or 11 pi over 6 is down here. Now if you make one full rotation around the, around the unit circle and you still end up here, that's a coterminal angle with 11 pi over 6. How did I get to it? By adding 2 pi to that. Right? So we could add 2 pi to these values any multiple of times. That's why we add this 2 pi n, right? We're saying a rotation of 2 pi n times, where n is a value, is an integer value, right? So our answer is here. Be careful though when you're doing this in Math Excel, read the directions. They're probably going to say, solve in the interval from 0 to 2 pi. If that's the case, then we only accept these two values. Right?